We're now going to look at what's called the leaving group in these substitution reactions that we're studying in this chapter. If you recall, the overall substitution reaction looks like this. And what we have looked at a little bit so far is the alkyl halide. The alkyl halide is acting as the electrophile in this reaction, and it's going to be attacked by the nucleophile. Oftentimes the species that we say is getting attacked, we're going to refer to as the substrate in this reaction. So the alkyl halide will be acting as the substrate in the substitution reactions that we are studying now. We also have looked a little bit at the solvent. And what we know so far is that for an SN1 mechanism, it seems that tertiary alkyl halides work the best because they make the most stable carbocation, and that protic solvents are preferred because they solvate carbocations very well, which is a stabilizing effect. Two components of the substitution reaction that we haven't really considered yet are the leaving group and the nucleophile. The leaving group in this case is the group that gets kicked off during the course of the reaction, that leaves. And in the case of this SN1 reaction with the alkyl halides, of course, it's the X that's leaving in the form of X- that acts as the leaving group. In terms of leaving group, it's this simple rule that you will need to follow all throughout your study of organic chemistry, and that's a weaker base is always a better leaving group. As I mentioned, the leaving group in these SN1 reactions that we're studying with the alkyl halides is going to be the X, the halogen itself, and it leaves in the form of X-. Recall that when you go down the periodic table, like in the halogen series here, as the atom gets larger and larger, it can better accommodate electron density. So I- is going to be the most stable or the weakest base, and F- is going to be the least stable or the strongest base. And so I- in this series will be the best leaving group, while F- will be the worst leaving group.